Okay, so 2D lists and 2D data structures are really useful, especially when doing like grid-based systems and things like that. So what we've got here is we've got a 2D list. So we've got a list, look, which are these two external brackets. And within that, in each item, look, so separated by a comma, we've got another list. So we've got three lists within inside one big list. So if you imagine this like a noughts and crosses board, we could say this could be the top row. So index position 1 is the top left, 2 is the top middle, 3 is the top right. Then you could say 4 is the middle left, middle right, and 7 could be the bottom left, bottom middle, bottom right. So you can see how you could represent this as a grid. So to access the whole list, we obviously print 2D list. To access an individual list, we just do that. So position 1 of the big list is that list there, 4, 5, 6. If we then want to index that, we can. So index position 1, 0 of a 2D list goes to the position 1, which is the other list, and then position 0 of that list. So we can access bits individually. If you want to loop through, you can loop through. Oh, sorry, I'm trying to be quick instead of typing it all. You can loop through a list like this. So you can say for group in 2D list, so group being this is going to loop through. So that's going to be the first instance. Then on the second loop, it'll be that. Third loop, it'll be that. And then we can loop through the item in the group. And then we can print the items individually. So that's a way of looping through every item in the thing. If we wanted to just loop through a specific row, we need to do something like this. All right, so we're looping through 4 item in this 2D list, position 1. So position 1 is 4, 5, 6. That's the position 1 of the main list. If we then print the items of that, then it's going to print 4, 5, and 6. So it's a way of looping through just one of the sublists. You can do this again with columns. With a column, we want to loop through for group in this list. So we want to loop through, so that's first, that's second, that's third. But then we only want to look at an individual item from those with a specific column. So if we print the group, it's going to be that, then that, then that. But we do position 1. Group of position 1 is there, then it's there, then it's there. So when we run it, it'll print 2, 5, 8. Only a couple more things. You can add to a 2-dimensional list. So this is going to look a bit weird, but you can add. I've added orange to the end of the list that's at position 0, so you can add it to a sublist. You could also add it to the main list. So if I do that, orange is in there. You don't have to have one type of data in a 2D data structure or any data structure. You can have a data structure that's full of strings, other data structures, integers, whatever. So you see here I've got a 2-dimensional list in 3 positions and a 1-dimensional list at that position there. But yeah, again, you're typically using these for grid systems, so you won't really come across that. But you can remove as well. So you can do all the things you do with lists or other data structures. You're limited by the structures you're using, but storing data structures within data structures is possible. So this 2D list at position 0, which is this one, don't remove 1, which will remove 1. So you're only left with 2, 3 in the first one, and then the others will be the same. Okay, you can also have dictionaries and tuples inside another list. So I can have there, I've got a tuple and then 2 lists with inside a bigger list. It's still a 2D data structure, but it's just obviously then I'm limited on my tuple, but I can't do as much with it because it's tuples immutable, but a list is mutable.